Welcome back to another video of Math Times Cool. In this video, I will be showing you guys how to prove two triangles are similar. Okay, so let's say you have two triangles, right? Let's say you have this triangle and that triangle. Let's call them A and B. So let's say you were told that, I don't know, one side is proportionate to the other. So not congruent, but proportionate. So there is a ratio between this length and this length and this length and that length. Let's say we're also told that these two angles are congruent. You gotta prove that these two triangles are similar using side and side. So let me first clear up some misconceptions that you may have with similarity with postulates like side. You're not proving that all three sides are congruent. That's where congruency. You're proving that they are proportionate, that they are proportionate. So let's say with these two triangles, this was 4 and this was 2 and this was 6 and this was 3. Let's just say that you would know that they are similar because of side angle side. You know that two sides are proportionate, and you know that one angle is congruent. So this is how you prove that two triangles are similar using side angle side. You know that one side, two sides are proportionate. See, 6/3 is equal to 2. See, proportionate. And then you know that one angle is congruent. So yeah, the angles have to be congruent. So now let's try side. So you have two triangles again, A and B. Again, let's say it's like 10, 20. And then let's say 11. No, yeah, sure, why not? So 5, 10. And then I'm just gonna say 11/2, or 5/5. Okay. Okay, so you can see that that all three sides are proportionate, because if you were to multiply this length by 2, you get 10. 10 times 2 is 20, and the 5.5 times 2 is 11. And then so you have successfully proven that these two triangles are congruent. Similar using side. These two triangles are similar using the side postulate. Okay, now let's look at the last one. So last one is angle. For this one, it's pretty straightforward. You just have to prove that two different angles are congruent. Or you have to prove that two pairs of angles are congruent. So as you can see in this example, let's say this A and B, this angle is congruent to that angle and this to that. So there are two angles that are congruent, and so these two triangles are similar. Okay, so let's actually do a few problems. So let's say you have these two triangles, right? And you were told, actually, use the black pen. Let me get this out. So let's say you have that, and bring it up, and you have this. You move that. Let's say you have these two triangles. Wait. Whoops. Okay, so you have these two triangles, right? And you're told that these two lines are parallel. So let's do a statement reason table. So you have the statement here, and then you have the reasoning on the left. So let's say that this line is L and M. So the first thing you would say, the first statement would be that L is parallel to M. The reasoning being it is given that they are parallel. And then so by this, you can say that let's name these angles like A, B. Then this angle A, B, then C, and then this angle X, Y, Z. Okay, so we know that A is congruent to Z because alternate interior angles of parallel lines are congruent. Okay, that's a lot. This is a lot to write. Okay, and then we can also say that for X and B and X, because they're the same thing, because alternate interior angles are congruent. And then now we can say, let's just name these two triangles like J and this one K. We can now say that triangle J is congruent to triangle. Whoops, you have to add the angle sign because they're angles. That triangle J is congruent to triangle K. Then the reasoning being angle, because we proved that two angles of these two triangles are congruent, and then so we could say that the reasoning being angle. So let's say, I don't know. I'm just gonna make more variables up. Let's say this is I don't know. Let's say like this is E and this is F. You have to prove that EF, and then let's do like I don't know, OP. You have to prove that there is the thing that you're trying to prove is that O over P is equal to E over was that K? Yeah, K. No, this is R. Let's just say R. Okay. So we can now prove that that E. We can prove, O over P. Or is actually, no, it's not. Oh, whoa! I just caught a mistake. So that wouldn't be the right symbol. That's a congruency symbol. So the symbol would be like that, showing that they're similar. So you can say that over P is equal to, or congruent to E over R. The reasoning being corresponding. I'm not gonna write it out because this is way too long. I'll just say it out. So it's corresponding parts of similar triangles are proportionate. So corresponding parts of corresponding parts of similar triangles are proportionate. See, that would be the reasoning for that. Okay. So I believe we have done everything in this video. Actually, let's just do a few basic like similarity problems. So say you have this triangle. I don't know. Let's say like you were told that. Actually, let's do this. Let's say that X is Z. You see that Z was dilated by 2 to get X. So Z was dilated by 2 to get X. And you were told that. Let's say that this is just hypothetical. Let's say all sides were 1. So all the sides on X would be 2 now because they have been dilated by that amount. Because it's been dilated by 2, and so the length would double. And then so all lengths would be 2. Okay, now let's do an actual example. Okay. So yeah, triangle X, Z again. So like 4, 5, 3. Okay. I don't know. 5, 4, 3. So whoops. So you were told that these are the points. To find the other points, you just multiply by 2. So 6, 10, 8. Other than, let's say you were just given X, you just divide by 2 to get the coordinates for Z. So 3, 5, and then 4. Okay, so hopefully in this video you learned how to prove that two triangles are similar to one another. I hope you enjoy this video. I will probably be uploading this on the 23rd. So yeah. So thank you. Goodbye.